Hey everybody, welcome to my talk on Canvas performance tips. You will learn how to pixels well. As Adam mentioned, my name is Angelina. If you are interested in complaining about code, sometimes retweeted articles about code, a curated selection of red panda GIFs, or perhaps you're just interested in the slides from this talk afterwards, you can follow me as Angelina Magnum on Twitter. So whenever I start writing code on the internet, which is basically all that we do, invariably, when I'm learning something new, I come across this idea, that you should just write code, worry about performance later. And in essence, this is actually mostly true. You don't want to try and over-optimize too early. Otherwise, you're spending a lot of time tweaking things which may not have a larger impact on the project you're working on. But more importantly, in my opinion, you'll get distracted from all the code that you should be writing to get the project done. So the person that wrote this, or that writes quotes like this on the internet, and you often find this attached to performance-related articles, I think is mostly correct. But I don't think entirely. I think we should think about this just a little bit differently. I like to say now, as of yesterday, optimizations are a last step. Best practices should be every step. So I'm hoping today that I give you some ideas about best practices working with Canvas that are easy for people that are both new to Canvas and maybe seasoned people. I hope that I teach you one or two things that you didn't already know. So first of all, let's travel back in time to the 1990s. So once upon a time in the 1990s, we had some limitations in our browser, right? There wasn't a lot we could do with drawing. We had HTML, which, before the word web application was even a thing, we could create, documents that were just mostly like documents. We got introduced to CSS, which provided some styling for said documents, and it actually took quite a while till we could do sophisticated drawing. These days, in 2014, you can do really sophisticated CSS transforms and animations, and if you ever go over onto CodePen, there's some really fantastic examples of the stuff that people are doing there. So when early programmers of the 1990s came up against the limitations of the browser and thought like, well, I want to make a game, and keep in mind, JavaScript wasn't cool yet. It was still, like a new kid on the block. And when people were met up against the boundary of the browser, they sought to extend the browser using plugins. So a couple of the early things that we had for drawing on the web was VRML, or VRML, which was a standardized markup language for describing objects in 3D space and applying textures to them. And that kind of was a thing, but then it really wasn't. It was superseded by something called X3D, and then it was superseded by like everything else. And then there were these things, Java applets. This one still exists. You can play it on the internet, and you should check it out because it's really a blast from the past. Although the Java, the latest Java runtime for the browser will warn you that there's like tons of security exceptions. I can at least vouch that this didn't install viruses on my computer, so if you do feel like going into the past, at your own risk. So at least, there's at least two. I mean, there's more than just the three I'm going to talk about, but of course there's also Macromedia Flash, which eventually went on to become an Adobe product. And Flash is still around. Don't know for how long. And that's for good reason, because we have some better methods for drawing in the browser. We have APIs in the browser for doing drawing and creating animations. So we've got this canvas tag, which is basically all you need for drawing, but then there's also this SVG thing too. So when do you use SVG and when do you use canvas? We'll explore that in just a little bit. First of all, let's take a look at a simple animation with Canvas. And I've got like a little code pen up here that I whipped up. You can see on the left-hand side, I guess that's a little bit small. Let's see if I can zoom in and not have this be terrible. Oh, that's kind of okay. Collapse of pane. All right, so we've got just a canvas element there, and over on the right-hand side, I'm grabbing the canvas element, throw it into a variable, set some other variables like width and height, so I don't have to recalculate those every time I need them. And then there's this thing called the context that I call, I use Canvas, I get context, I tell it using the string that I would like a 2D context as opposed to a WebGL context, which we will get to. And if you're unfamiliar with Canvas, you can think of a context kind of like a toolbox in a sense. Much like a traditional artist that's drawing on a canvas, you will have a toolbox that's filled with things like paints and colors, brushes that can draw lines of various widths. And so I find that for people who are beginners, the best metaphor that I've found, and this is thanks to a friend of mine, is actually that you should think of the context kind of like a toolbox. We're not just doing simple drawing here, right? This is actually a really fabulous animating red square. It's basically the best animating red square. And what we're doing here is we've got this function called draw where we call request animation frame, and then we call draw there. And although that does look like recursion, what we're doing the first time we call it is we're actually basically saying to the browser, please, the next time you have a frame for animating, give it to me, and then do all this stuff. And then we're telling our context that we're kind of like dipping our brush in this bright blue color, and then drawing from the origin of 0, 0 in the top left, we draw and paint the whole canvas blue. And then we hold on to that, we save it, and then we actually translate our origin points for where we're drawing from, and then we rotate, and we do the same thing again. We dip our brush in this really bright red color, and we do a fill rect, which is painting a rectangle, and then we restore it, and bam, you've got this animation. So, I mean, we did that in, there's a lot of comments in here, but less than 50 lines with really verbose comments for beginners. So that's, kind of okay. Oh, wait, that's a terminal. You don't want that. Where's my talk? All right, so that's pretty simple. The interesting corollary here is that there's a simple loop that's updating the canvas, and one of the things I've noticed is that if people do not have a computer science graphics background or they've never messed around with Canvas, some people just actually never thought like, well, how does a video game work? And actually, a video game works in the simplest sense by updating the screen in a loop, and then you add gameplay and game state to that, and that's how a game is made. So if you've ever wondered like how video games are made, even at the highest level of AAA games, this is essentially a core part of how games work. So we did that with Canvas. Now let's take a look at this thing called WebGL. And let's try it. Actually, what we're going to do is we're going to take a look at an example that draws and animates the exact same square. Okay, so over on the, nope, that's not the one. Okay, over on the left-hand side here, we have, we've got Canvas. Okay, but there's some other stuff here. We've got this thing that's called, in some script tag here on its own, a GL frag color. And that doesn't look like something I've seen in JavaScript. Then we've got this other thing, GL position. I've never seen that before. And over on the right-hand side here, yeah, it's pretty short, right? Oh. Ooh. This is all to draw one animating square. Oh, no, I'm not done yet. Look, keeps going. Woo! Okay, so there's this WebGL thing. It's considerably more verbose than the Canvas API. That's an observation we can make so far. And WebGL, for the uninitiated, I assume that most people probably heard about WebGL in passing, at least. It's using basically the OpenGL language on the web. It's like almost like a port of that to basically get closer to the metal, push off a bunch of calculations and graphics work onto the GPU. And so it has significant advantages over just the 2D Canvas API, which I introduced, and we're going to talk a little bit more about that. So yeah, that was a simple animation with WebGL, and honestly, that thing was so long that, we just can't even really go through all of it. Oh, that didn't scale well, but you get the point. I love this guy, like, so much. All right, so if you're not coming from an OpenGL background, and you want to use WebGL, you basically got to learn a new language. And you've got to be introduced to these things called shaders, which are kind of an important concept. You can't really get around that either. So shaders simplified almost too much, and anybody who's a pro in hearing me say this stuff is going to be like, but not actually, but not all shaders. Oh no, this didn't scale well. I wonder if I can refresh this. Give me a sec here. Let's see. Yeah, there we go. So shaders simplified almost too much are basically individual programs that run on the GPU and give your 3D drawings life. And what I mean by that very simply, we've got two kinds. Vertex shaders, they transform position. They run once per vertex in a mesh before these other things called fragment shaders. And a mesh you can think of as a bunch of connected vertices. Fragment shaders run once per pixel between vertices to essentially paint your 3D objects. You can't make 3D stuff with WebGL without using shaders. So I'm just sitting here talking about Canvas and WebGL, and then I mentioned this thing called SVG, Scalable Vector Graphics, and you're probably wondering, like, how do I know when to use which of those? So let's go through like some of the reasons you might want to use one or the other. So scalable vector graphics are pretty interesting. So you want to use scalable vector graphics when you want something with a DOM-like internal hierarchy. SVG has the ability to have these nodes that behave very DOM-like, and they'll fire events for you. So if you're looking for something with simple interactions, A+, SVG is pretty cool. You want to be able to easily draw non-square shapes because it's vector-based. It does really, really nice smooth curves, so that's pretty awesome. If scaling dimensions is important, then this is actually pretty fantastic, again, being vector-based. We'll talk about what to do to properly scale a canvas if you need to and still keep things performant. But if possible, just don't resize your canvas. Depending on implementation and stuff, the interpolation can make it look really poopy. If you don't need a billion nodes, because depending, again, on SVG implementation, having lots and lots of nodes in SVG can degrade performance. I did talk to some people, and someone on platform mentioned that it really does vary by implementation. In fact, there's some stuff that seems to be for some SVG implementations that could be pushed onto the GPU, but isn't. It's done on the CPU, and rendering like lots of curves, and it gets to be a pain. So node use, be judicious. If you want to display a mostly static chart or create a simple point-and-click game, simple user interactions with really smooth, nice graphics that you want to scale well, that's when you want to use SVG. So a cool idea is rather than using SVG for a game, you could build like a game's level editor using SVG, and that's probably a pretty good use. So when do you want to use Canvas? And we mean the 2D Canvas API, the very first example that we use. So maybe you don't want an internal structure, DOM-like structure, handling events for you. You want control over which pixels exactly fire events, so you can have ultimate precision by controlling each individual pixel. Probably you want something maybe retro fabulous, because 8-bit style art, it turns out, kind of hard to do with Canvas, but kind of hard to do with SVG, but much easier to do with Canvas. So recommend, if that's the style you're going for, that you're going to want to use Canvas. And if you want to make a fast-paced game, not just a point-and-click, something that's a shoot-'em-up, FPS, or if you want to display real-time visualizations and charts, Canvas is going to be your friend. Now, WebGL, this magic thing I was telling you about that can offload stuff onto the GPU, get you better performance. When performance is the most important thing, you want to use WebGL. And in fact, you can still draw with WebGL in 2D, which was the example I showed you. Obviously, the most popular thing to do is draw in 3D with it. But if you draw in 2D with WebGL and you deal with all that verboseness, you can actually get much more performant 2D animations, 2D games than just drawing with the Canvas API. So that's something to consider if performance is an issue. And if you want to draw lots of 3D shapes. I'm comparing this here actually as well to a lot of 3D CSS transforms and animations. Not because like one or two of those aren't terribly performant. In fact, our browsers are pretty fast these days, right? But if you have lots and lots and lots of 3D shapes and lots and lots and lots of layers and transparency and effects, and you've got tons of DOM nodes, well, things are going to actually slow down quite a bit. So I would recommend using WebGL instead of doing that. Although I think the 3D CSS stuff we can do now is pretty wicked. So often, you think like you saw this like Angelina did like an example of WebGL, and I showed you how to simply draw. So it's basically simple. Now that you know one or two things about WebGL, you can basically, that's it. There you go. That was how to draw a square. Now go make a game, right? So it's not that simple, but there are lots of really excellent tutorials on the internet that will help you out with that. So I just wanted to make sure people sort of knew the appropriate uses of Canvas, SVG, WebGL, before we actually get onto the meat of everything, which is, of course, talking about Canvas performance and WebGL performance. So you might say to yourself, but I want to write JavaScript. I don't want to learn a new language. I mean, those shades were cool, but I don't really want to be writing shaders explicitly. That was just like a lot of code just to make a square. I mean, oh my gosh. But there are some libraries that will help you. The most popular one, of course, that a lot of you might be familiar with is 3JS, which abstracts away working with 3D and with WebGL. Tween.js is an excellent library for basically animating between smoothly. And then I found this other one that I think is really, really excellent for if you're doing 2D rendering. It's called Pixie.js. And it's like I said, a 2D WebGL renderer. But the awesome thing is it has a canvas fallback if you can't shove stuff onto the GPU. So that's really nice if you're doing 2D games and you're going cross-platform. Right. So when you're using a library, if it's written by somebody else and it's not something that has, a lot of community support, maybe it's like a new game framework or something that you found, and you're kind of like, well, the screenshots look really cool and the demos are really cool. Maybe I'll use this. Something like Three.js is, I guess, a little bit battle hardened because there are a lot of people that work on it. My friend Soleil is here. She's actually the author of Tween.js, and we were talking about Three.js last night. She's like, yeah, there's this guy in Slovenia who's amazing, and he spends like hours optimizing all the shaders in every browser. So to that guy, hats off to you. So he's done a lot of the hard work for you, making sure that your CPU and GPU are not doing extra work. However, imagine a situation where you have a set of functions. Someone's created like a nice API to abstract away some of this work for you, and you have you call canvas, like clear the canvas yourself, and then maybe you call a function that is opaque to you because you haven't looked at the source code, and it's called prepare canvas. So intuitively, you might be like, okay, first I'm going to clear the canvas, and then I'm going to prepare it, and then I do some work. Sure, that sounds intuitive to me, but what happens, if prepare canvas also calls clear canvas? Then you're doing what's called redundant draw calls. So, and that's just doing work twice. Like, come on, we don't want to do that. So let's actually take a look at that. One good way to inspect this is using the canvas inspector in Firefox, which we landed, I think, just a couple months ago. We actually announced it at GDC. And actually, use the shader editor too, which will actually pull up WebGL shaders. I'll show you in a moment. Because if you are somebody who is a little bit curious about under the hood, you can actually live edit those shaders in the browser and see them updated in real time. It's an excellent learning tool. Like when I was diving into this stuff, I was like, oh, okay, this isn't so bad. Having that immediate feedback is really great, kind of like using a REPL. All right, so let's go through this step by step, frame by frame. So this is an example here of inefficient canvas usage, actually. And it's a very simple example, so it's deceptive. But we'll actually take a look here with the canvas inspector. Let me see if I can make this bigger. That's kind of getting bigger, maybe a bit bigger. Okay, we'll see how the inspector responds to that. Let's scroll up here a bit. And I got to reload the page. Click on this to record animation frames call stack. Okay, so what we have here is basically the canvas inspector, when you grab a snapshot of it, will show you basically all the draw calls that are going to be executed in order to implement like the next step of animation. So, I mean, this is a really simple one. So at the bottom, we've really got these like 3 frames right here. For more sophisticated stuff, like if you go to the WebGL playground and take a look at some of the examples there, and that's like on Heroku, I believe, then you can actually run some of these in the canvas inspector. You can go into the shader editor and play with them and then really see what's going on under the hood. And the the WebGL playground on Heroku is actually pretty good because it's got like the live code that you can edit in the page anyway. But this is really good for seeing performance. So if we look actually at the code here, is my bad canvas example. I've got this all stuffed into the head. Don't actually do this. We've got here, let's see, request animation frame. Looks kind of similar to our example when we were animating there. You can see that we're doing a fill style right here and a fill rects. And then we're calling this function. I was kind of using this example of prepare frame. If we go over into the canvas inspector, you'll see that we've got some duplicated calls here. Fill rect is being called twice, and stroke style is being called twice. There's no reason to duplicate effort. If we go back into our code and we take a look, and we'll see that when we're calling prepare frame, there we go, that fill rect is called, and draw circle also sets a stroke style as well. So this is a really obvious example of duplicated draw calls. From inspecting a couple games over the last while, I recognized that there are often cases where things look like repeat draw calls, but sometimes there is like some meaning towards, behind the scenes that's not obvious to why that might be there. But when you do see those in, the canvas inspector, it's a pretty good indication that you might want to take a look at that in your code, or look at the library that's you picked up and didn't really vet very hard on the internet, because reducing the number of these redundant draw calls can actually make a difference. Now this example isn't using shaders. I do have that WebGL example again, the one that we were using in the code pen. So if we inspect that and we pop over to, I don't have the shader editor, so let's turn that on. If you are looking for the canvas inspector and the shader editor, you just got to click on like the sprockety thing in the Firefox DevTools and enable the shader editor. There we go, awesome. Reload the page. And so what's going on here is when we were taking a look in that code pen earlier, we had some script tags that had these things called GL position and GL frag. And these things, of course, are our vertex shaders and our fragment shaders. So actually what we can do is we can actually go in here and we can modify some of the stuff here. What happens if I change this to a 2? No, it's not going to do anything. There we go. Yeah, pink square. So you can see that that updates in real time for you, which makes debugging and learning, I think, this stuff a whole lot better. Let's get those out of the way and keep on going. Step by step, frame by frame, everybody. So now let's dive right into those performance best practices that people are, here for. The first thing is you want to make sure you use whole pixel rendering. And what that means is when you're specifying, like a draw operation, don't use floats if you don't have to. If for some reason you're calculating something dynamically and you get a float, call math.floor or use bitwise operations on it in order to make nice round numbers. Because the CPU ends up having to do a whole bunch of extra calculations to round them anyway to give you a nice anti-aliasing effect. So just try and stay away from that where possible. Cache your drawing in an off-screen canvas. Image copying is actually cheaper than redrawing pixels. So what you can do is something kind of like this. You just create a canvas, don't add it to the DOM, and then render some stuff there, and then render it onto the canvas. And that actually is a really great way to deal with performance. So if you're doing something that has multiple layers, maybe you're doing kind of like a parallax background. If you've ever seen if you ever pulled apart old Super Nintendo games and stuff and seen all the layers that go into that, use kind of the same principle. Use sort of transparency and move the layers a little bit, and you can. That's actually a lot better than using just one canvas, because often you're just using part of each canvas to create a whole scene, and you're drawing just little portions of the canvas rather than one big thing all over and over again. That being said, only draw what you have to. There's some tutorials out there that I recommend you poke around and find that will show you how to only draw what you have to. That is to say, don't redraw the entire canvas, only draw pixels that have changed. Like basically, you can see the recurring theme here is don't do any more work than you absolutely have to. If you have a large unchanging background behind your game, like it literally is a static thing, then just apply it using CSS. Don't draw it in Canvas. There's just no reason to do that. So that's a pretty simple one. I am confident that most of you, I hope, know how to use CSS. You guys are JavaScript developers, so yeah, large unchanging background, apply with CSS. And here's just an example of using multiple layers, actually, with multiple canvases, which totally should have been with the previous example, but haha. And then, so this is actually mostly applicable to charts or maybe a game where you're dealing with real-time data. So latency is a thing, right? That's kind of a problem. I've seen people do real-time charts, and the data will kind of come in and it stutters, and I know immediately that they're not using a queue to deal with that. So what you want to do to animate smoothly and avoid these latency issues is don't just animate stuff when it comes in. When you get your data, put it in a queue, and then at some regular interval that you've determined mitigates some of your latency effects, then pull that and pull off the next bit of data, animate that onto your off-screen canvas, and then when ready, animate that onto your canvas that your user can see. If you scale the canvas at all, use a CSS3 transform, because those are GPU accelerated when done right, and that's what we're looking for here, so that's pretty fantastic. And here's just an example right here of doing that. So you can actually do that in JavaScript, or you can apply it using CSS, and maybe it'll just scale boop to the viewport that you're looking for. I figure this stuff is actually pretty simple for you. So don't write your own matrix operations library. There's a bunch of libraries out there that have been already written and already obsessed over for those optimizations. And at some point you might be like, well, I don't know. I don't like the API surface of this library, so I'm just going to write my own. Just don't. Just don't, because honestly, it takes a lot of time in debugging to get right, and unless you're somebody with extensive background, you're probably going to mess it up, get some of the calculations, use an algorithm that's not super optimized, and impact your own performance because you were, ambitious. I mean, that being said, maybe don't ship it in production for something you want your end users to use, and make it a side project. You can be ambitious and write your own matrix operation library, but get lots of peer feedback on that sort of stuff, and just mostly don't do it. So here's some other stuff that affects performance that's not necessarily directly a Canvas thing, but definitely causes problems. Avoid frequent calls to local storage. Every time you do that, it can actually be a performance hit. So do those at particular intervals. Like, for example, if you've got a game with levels, do that at the score screen in between levels. If it's a game that involves a lot of real-time stuff and you want to somehow save state so that if a user gets disconnected, they can reconnect, do that in between turns somehow. Just find an appropriate time to do it when things aren't animating and you're not doing a major draw or update, basically. So just choose where or when and where you call to store things to local storage carefully. So when you're creating something and doing stuff with Canvas, don't just keep creating new objects willy-nilly. Reuse them from a pool. Because if you don't, you're going to get a graph in the Chrome timeline that looks something like this. So a few of you might know, of course, what's going on here. It's all like, ooh, and it kind of just drops off. And this is a game I found, actually, that's really simple version, of course, the really popular 2048, which, by the way, you guys should check out 3s. I think it's a way cooler implementation. But somebody here has gone and implemented a 3D version of it, and it's pretty simple, right? Like, I started playing this, I was like, oh, yeah, this is really fun. Ooh, it's animated nicely. But the first time I started playing it, I mean, my MacBook Air can actually handle some pretty decent games on Steam without chugging and heating up. This game, it looks really simple. It was like, oh my God, what are you doing to me? And it like got really, really warm. And so, I mean, looking in the code was actually, the code is actually not all that straightforward. It's up on GitHub, and you know, there's a couple things that look like redundant draw calls, but they were in 3JS, so I'm not going to kind of trust the 3JS people. But, you know, looking at the timeline in Chrome, you see this. And what's happening there is, when I looked in the code, this person is actually creating new tween objects all the time, rather than reusing them. So it's like new object, new object, new object, garbage collection. And garbage collection is a performance hit, so please reuse objects from an object pool. You want to keep the garbage collector bored. I know it's that awesome feature to have, but keep it as bored as possible. And so this here is like the biggest wall of text you're going to get in the presentation, but it's a simple example. And of course, I'll give out the slides afterwards, because this is a little bit longer. But you want to basically initialize a pool of common objects, and then pull out an object, use it for something, put it back in the pool, and then initialize it for something else. And that actually will be a lot better, because you're not doing a whole bunch of garbage collection at these various intervals that will then make your animation and your game stutter. If I keep going with that 2048 game and we start getting more and more cubes, and I just keep going and flipping it around, it will start to stutter. Another tool to use is an FPS counter. You can actually find stats.js, which I believe is I think I was talking to John David Dalton yesterday. He made that, and then now it's kind of in 3JS, or Mr. Doob uses it. So there's like a little JavaScript implementation. Chrome, if you go into the dev tools, press escape while you're in there, you'll see a little rendering tab, and they have an FPS tool as well. That's really cool. It actually looks really badass. It makes me feel like I'm in the future. It's like red and black and moving lines. And then Firefox has got a really nice integrated FPS widget that's going to be shipping with our profiler once we ship our brand new profiler. So that's a thing. So another, of course. So basically, yes, another good metric is to look at your game and see when your frame rate really fluctuates, or when it just drops down to 10. Like if I keep going in this 2048 game, I've got limited time, so I'm not going to pull it up. But trust me, if you just find this game, if you look for Cubics 2048, you'll find it, and just run an FPS counter as you keep doing this, and you'll watch it go pew all the way down. So very fun game to play regardless, though. So some miscellaneous micro optimizations. Remember I said these, up until now, these are mostly best practices for doing your Canvas stuff. If you get to the end and you really do want to try and get a little bit more bang for your buck out of performance, these are a few tips that I picked up from really great articles on Mozilla Hacks, talking to my friends who are higher level wizards than I am at Canvas, and there's also some good stuff on HTML5 Rocks as well from people at Google. Use bitwise operators instead of math.floor, a little bit more performant. Clear arrays with length 0 to avoid creating a new array. Use if-else over switch. And actually, I have an article that I can link to when I send these out that has JS perfs for these. Use date now over new date. Avoid shadow blur. You can do that to apply effects to primitives, but that can actually be a performance hit as well. So, oh my God, this is so much stuff, right? So everybody's either really quiet because they're like, oh my God, I'm in awe, or holy shit, I'm totally confused. But that's good. Hopefully whatever I've said to you today makes you think okay, now I've got this handy bag of tricks for working with Canvas. I don't need to be afraid about going out there and experimenting, because you've got these ideas you can keep in the back of your mind, so that your Canvas stuff ends up being really fun for your being really fun for your friends to play with on probably most devices. In fact, a lot of these tips came from tactics that people use for shipping games on Firefox OS, which the phones that we're shipping are, they're not your iPhone 5, and that's on purpose, actually. They have much less power, much less memory than the fancy phones that probably you or I have. The idea is that we're shipping these to emerging and developing markets and pricing them competitively so that people that would buy a feature phone will instead maybe be introduced to smartphones and spend more time on the web and stuff like that. But actually, a really great metric is that Firefox OS phones are super cheap. You can buy them for under $100. If your game runs really well on one of these less powerful, memory-constrained phones, you can be pretty confident it's going to run really well on other devices, actually, because you're only ever as best as your worst-performing case, in my opinion. So that's basically it. I hope you enjoyed this slideshow of